Now we're going to look at graphing variations of y equals sine x and y equals cosine x. So how to sketch the graph of a function y equals a sine x. It's a similar process for cosine. Identify the amplitude, identify the period, start at the origin with the function increasing to the right if a is positive or decreasing if a is negative. At x equals pi over 2b, 2 times the absolute value of b, there's a local maximum for a being greater than 0 or a minimum for a being less than 0 with y equals a. The curve returns the x-axis at x equals pi over b. So this is for definitely for sine. Cosine's a little different because these values here are going to be different. The local minimum for a being positive or max for a being negative at x equals 3 over pi over 2b. With y equal negative a. And the curve returns again to the x-axis. So here we have one. There's no phase shift on this. I was able to kind of capture a graph, but we have to change some values when you see this. So we see our a is negative 2, so that tells us something. But our b is pi over 2. So when we look at 2 pi over pi over 2, that's going to be 2 pi times 2 over pi. So that pi's cancel and we end up with 4 as our period. So I'm just going to cross these out here and just go with my own. Okay, I just couldn't find a blank one. Later on, you'll see some blank things that I created on a website, but whatever. Here we go. The fact that it's negative, it's going to be going down instead of up. Let me label this. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So it'll start here since there's no phase shift. And normally it'd go up, but it's going to go down. So here's our key components. It's going to bottom out then, and our coefficient was negative 2, so it goes down. Then it'll come back up to 0 at 2, and then it's going to peak, then come back, go down, come back, peak, come back. So it looks something like this. And then likewise, it would come up there, back here, down here. Okay, we got a couple more of these we're going to do. Okay, wasn't that fun? I know I missed the point here, but there. Okay, and you can always use decimals or something to graph it to see what's going on. How to sketch the graph of a sine function with a phase shift now and a vertical shift. So we're going to put it in this notation. Identify the amplitude, identify the period, identify the phase shift, and then draw the graph. And then shift to the right or left by C over B and up or down by D. Okay, so let's take a look at this next one. We have an amplitude of 3, so A is 3. Go back to blue, I like using blue. My B is pi over 4. So 2 pi, this is for the period, over pi over 4. It's going to be 2 pi times 4 over pi. It's going to give us 8. That's a pretty good period. And then we're going to have our phase shift is going to be C over B. So pi over 4 over pi over 4. So it's just going to be 1. So we might want to look at our graph. Yeah, we're going to have to think about this for a second on labeling this. 3 works on this graph. I'll get rid of these again. And we don't have a vertical shift, so that's helpful. Okay, it's going to go to 9 this time. So if I still stick with 1, 2, 3, 4, 5, 6, 7, this stops at 8, so maybe we'll go on to here and say 9. We have our -1, -2, -3, -4, -5, -6, -7, -8. So the phase shift, this is a sine, so instead of starting here, it's going to start there. The phase shift of 1. Positive leading coefficient means, now this is my period is 1 to 9. So halfway through that, it's going to be crossing back here, and it'll be crossing there. Halfway in here, at the 3, it's going to be peaking at 3. Halfway between 5 and 9 at 7, it's going to be bottoming out at -3. So we're going to get that kind of a graph. It's also going to go back. So this is going to come down to -3, and then we're going to go to 0. And 2 more, we're going to be at +3, and then 2 more back here. So continues on this pattern back this way. Okay, that's what it looks like. And let's go on to this. Given y equals -2 cosine of pi over 2x plus pi, we're going to graph this one. So we have a couple things. Our amplitude is -2, so the absolute value of -2 is 2. And this one, we're also going to be rescaling it. Okay, but given its cosine, it does have a phase shift. It's going to be going, normally it would start up high, but this one would start down below, but then shifted. My b is pi over 2, so the period, it's going to be 2 pi divided by pi over 2, which is 2 pi times 2 over pi, so it's going to be 4. So let me get rid of all this. Get rid of all this. Okay, so that tells us that, oh, we got a phase shift too. Our c is pi, so we're looking at pi divided by pi over 2. So pi times 2 over pi, which is 2. So instead of starting at 0, I guess I'll scale this too. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. Okay. So it would have started at 0 here at -2 or 2. Would have gone to -2 because of that leading coefficient's negative. And now it's phase shift by 2, so it's going to be here. So our whole period is 4, so it means we're going to have 2 to 6. It's going to be back to that location. Now in between, middle in between, it's going to be the opposite here. It means we're crossing at 3 and at 5. So we're going to get this kind of a curve like this. And we'll carry on. So 6 to 8, that's half of the period. So it should get back to here again. So it's going to cross at 7. Same thing here, cross at 1, be up there. Well, that's really funny, because now it starts like a cosine. But with that negative and then the phase shift, it is behaving like a regular cosine. That's a positive. Okay. I'm looking at, oh, well, we're just going to stick with this, but the original problem had a +3, and I guess I missed copying that down. Then we're going to be here, and then down at the bottom, then here, then up here, down, crossing up top. So we get a curve like that. Okay, and that's what that curve looks like. That was fun. And we'll stop with that.